Good morning, everyone. So this week for homework, we are going to be performing an experiment with hydraulic jacks. So the first step is to write a hypothesis. So write a hypothesis that describes how the pressure in a hydraulic jack creates a mechanical advantage. So I want you to think about how pressure, how does it get amplified when it goes from a small area to a large area? How does it create that mechanical advantage? So once you have that written down, you'll then write down your observations. So your observation should be in a table similar to this. So the area of the plunger, your force needed, and then it tells you which syringe is being pushed on, so 10 mil, which one is holding the 1 kilogram weight, the 10 mil or the 50 mil syringe. So you'll have that, and then force needed. So I will tell you if I need to push down harder or if it was easier to push down on them. Next, on this side, you can see I created a flow diagram of the procedure. So the first step is to measure the diameters of each of the syringes. It is 25 millimeters. So if you can see that, so it's 25 millimeters or 2.5 centimeters. So you should have that written down in your observations. And then for the small one, the diameter is 16. So you can see here. So you should have written down for the small, it is 16 millimeters, and for the large, it is 25 millimeters. Next, you need to calculate area. So area equals pi r squared. But this is the diameter, so make sure that you're dividing these in half to give you your radius. So in your observations, you should do that calculation to figure out the area where we will actually be performing our experiment. Okay, so I have our two 10 mil syringes in my stand. I'm now going to fill both of them up all of the way. So they're both filled up all the way. It then says to push one all the way down. And then the other one, you press down halfway. Awesome. So we now have our two cylinders. So we have our hydraulic press ready. So I have added my weight, and now I'm going to press down on this and see how much effort it takes. So I would say it takes a medium effort. So now I am going to switch one of these to a 50 mil syringe and then fill it up with water just like I did before. So I will be right back with the 50 mil hooked up, and then we'll see how much effort it takes. Okay, so I now have it set up. So I have my 50 mil and my 10 mil. I'm going to press down on this one so it goes halfway. Perfect. So next I'm going to add my weight. So I'm going to add it to the 50. And then I'm going to press down on this one and compare how much effort I'm putting in to get it to work. Oh, it's already moving. I would say I used less effort for this setup than my control. So this, I would say, less than control. So next I'm going to switch where these are so you'll have a good vantage point. So I now have my 50 mil syringe on this side and my 10 mil syringe on this side. So I'm going to add my weight to my 10 mil. And then I'm going to see how much effort it takes to get this to move. So, oh, there we go. So I had to push down with all of my weight on my palm to get this to move. There we go. So this took more effort than the control. So now that we have finished all 3 experiments, you should have for 10 mil to 10 mil, that was our control, and I said it was around a medium effort. Then 10 mil was the one I pushed on, and the 1 kilogram was on the 50 mil. That one I said took less effort, so you should say less than control. The 50 mil and is the one I pushed on, and the 10 mil is the one holding the 1 kilogram weight. I said that took more effort, so more force than the control. Then you should write down the area for both the small and the large. So once you have those 2 calculations done and that table filled out, you can then move on to the questions that are found in the textbook